Hello everyone, my name is Avant Mehta and welcome to my video for Lab 5 of ABE425. And today we're working on a simple joystick control device. Let me show you my hardware for the day. It's not as complex as we've seen in previous labs, but I'll show you how I connected this device to my Arduino. So my joystick has 5 pins. On the top is my ground, so I connected that to my ground of my Arduino. So my Arduino and my joystick are on common ground. Next I have my plus 5 volts, and that acts as an input to the joystick to power it, and that comes as an output of my Arduino. And next up I have my 3 outputs of my joystick, and that's my RX, RY, and SW, that's my switch, or what I call the button. And the focus of the lab for today is how I play around and analyze the data that I have from my joystick. I do that in 3 steps. The first step is collecting raw data. So if you look at the bottom right of my app, I'm updating my readings live, and I have a horizontal voltage and a vertical voltage. So first let's play around with these two and see what happens. If I move my joystick all the way to the left, I have a horizontal value of 0, and to the right I have a horizontal value of 5. That's the max nominal voltage. For my vertical, as you can expect in a similar fashion, if I move it up, my vertical is 5, and if I move it down, my vertical is 0. Then I have my button. My button was configured using an internal pull-up resistor, and what that means is that when my button is not pressed, it's quite high, almost as high as my nominal value, and when it is pressed, it's almost 0. When I do press it, it ends up being between 0.06 volts and 0.07 volts, as you can see here. So that was the first step, my raw data. The second step is displaying the information that I can infer from my raw data on this graph over here. So here I have my horizontal position and my vertical position. Both are on scales of 0 to 5, and that corresponds to the voltage that is being output from the pin to the corresponding output of my joystick. And for the button, the way I can infer whether it's pressed or not is I use the threshold value. For example, I used 0.5 volts as my threshold here. If my button voltage is greater than 0.5, I know it's not pressed, and if it's less than 0.5 volts, I know it is pressed. And the way I display that on my graph is that I change the color of my cursor from red to blue when the button is pressed. So that was the second step. That was displaying the information I can infer from my raw data. And finally, the third step is utilizing the data I have, and for that I decided to personalize this lab and give it some flavor by making a game that I can play using only my joystick. So if I press start, my game will spawn a box over here, and in order for me to score the point, I have to put my cursor inside the box, but that's not the only thing I have to do. I also have to make sure that the cursor and the box are of the same color. So for a blue box, it won't allow me to put a red cursor. I have to change my cursor to blue to score the point there. And in a similar fashion, I keep on doing this while keeping track of my points and my time. I'll put off my readings so that my app runs a bit faster. As you can see over here, it shows the current box color, which is red over here, and the cursor color, which is red. That depends on if my button is pressed or not. It shows me how many points I've scored since my last reset and how much time it took to score my last point. So let me reset and show you how I play this. It gets tricky because it requires some precision, but in 12 seconds I scored 6 points. That's pretty decent. It spawns a box between 0.5 and 4.5 on both the horizontal and vertical position, and it also chooses a random color every time it has to spawn a box, and it gives me 1 point for it. So that's some fun I had with this lab, and that's joystick control for you. And as always, thank you so much for watching my video. Have a great day.